Hello guys, welcome to Lim Gautek's YouTube channel. Today I am going to summarize Form 4 Chapter 1 Functions and give some tips in answering KBAT questions. So this is Form 4 Chapter 1 Function, and the first thing we learn in this chapter is relation. So relation is you map one to one, one to many, many to one, or many to many. And then your functions map an object to an image, a domain to a codomain, and the range is given by this symbol. Okay, so what is function? Function can only be something to one, relations. So this something can be many or one. So function can only be many to one or one to one relation. Okay, and these are the symbols of functions. This bracket can be represented by anything in terms of x, as this is a function in terms of x, and sometimes there might be undefined values for these functions, so x cannot be some values. Okay, and then what is discrete functions and continuous functions? Discrete function mean that the variable is countable, so you can only represent it by a chart like this or using a bar chart. And then when you say a function is continuous, meaning that it is uncountable, therefore every point in the graph is connected. So an example of a discrete function would be digital pulse, and an example of a continuous function would be analog signal. Okay, you guys will learn this in electrical and electronics module in the future. Okay, so now let's move on to the third part, the absolute value functions. So what is mean by absolute? Absolute means you turn everything into positive. You turn every negative, let's say your x is -7, so you turn it to +7. This means absolute. Okay, and then what is composite functions? Composite functions, the basic of it is if you have x and then you map x using a f n times, it will be mapping it n times. So the symbol is like this, and then if there's two different functions, f and g, and it is writing in this form, fgx, meaning that you map using a gx first, then use the f function to map the whole gx, g then f, if it's written as this. Okay, so the possible questions in this subchapter is that you might be given a fgx, and then given gx, you're required to find fx. Given fx, you're required to find gx. So here is tips that you need to know in order to solve this kind of questions, which is let gx equals to y, and then blah blah blah, using a substitution and algebra over side, you can solve this. Okay, and then let's move on to the last part, which is a inverse function. So inverse function, the symbol is given by this, f inverse x. So only one-to-one function has a reverse function. As you can see here in the second part, we know that function can be many to one and one to one, right? But only one-to-one function has an inverse. Why? Because if it's many to one, meaning you see, let me give you an example. Okay, if it's many to one, okay, do you know which path to go back? The answer is no, right? Because there's many cases that you can lead to this one, to lead to this answer. But if it's one-to-one case, you will have this to this, this to this. So you know which part to go back. So you can have an inverse only if it is a one-to-one function. Okay? So if f bracket f inverse, meaning that is equal to x as inverse, and the function you got back to the original value. Okay, so there might be a question that is, if you're given the inverse function of it, find the original function. Or if you have a original function, find the inverse of this function. So the starting point of this kind of question usually is let f inverse y equals to x, and then you flip it, continue it, make x in terms of y or y in terms of x, you can solve it. Okay, so thank you for watching this video. This is a summary of Form 4 Chapter 1 AddMath function. If you would like to see more AddMath and engineering mathematics video in the future, hit the subscribe button. See you all next time.